Hi, good afternoon. It's welcome to the panel today on Water Innovation for Africa, Sustainable Solutions for Water Management. My name is Wendy Green, and I'll be the facilitator or the moderator of the panel today. My background is actually agriculture and energy mainly, but I have done a fair amount of work in water. So I really look forward to taking you through the panel session today and introducing you to our wonderful panelists. So our panelists that we have today is Benoit Leroy, who's the Director of Operations at Nexus Water Alchemy. We have Desigan Naidu, who's the CEO of the Water Research Commission. And we have Gerardo Pretorius, who is the Head of Technical Water Solutions for OMI Solutions. So I'll give them each a bit of a chance a bit later to introduce themselves in further detail and give you a bit more background about their experience and what they're seeing in this space. But just really to introduce the topic, I think we all know that, without water, there is no life. And according to the World Health Organization, water scarcity affects 1 in 3 people in Africa. Africa cannot provide sufficient levels of water and sanitation sustainably for food security, health, survival, societal well-being, and economic growth. Water scarcity is obviously further exacerbated by population growth, challenges to economic development, urbanization, demographic shifts, and climate change. If we look at South Africa, and to quote Desigan himself in one of his reports, South Africa is classified as a water scarce country. With an average rainfall of 450 millimeters per year, South Africa receives almost 50% less rainfall than the global average of 860 mils per year. And I don't think that this is very different from many of the other African countries that we'll be talking about today. But when we talk about water issues and water management, we talk about issues in both the quantity and the quality of water. I think it's getting more and more difficult to ensure that the water we have is both utilized properly and it's kept clean, 2 very critical issues. We often hear people say that the next war will be over water. So the sustainability and quality of water is really critical for peace and security on our continent. So today, as I said, we'll be discussing water innovation for Africa. So as with every challenge, there are opportunities, and water innovation brings both solutions and opportunities. So we really look forward to hearing from each of the panelists about water innovation, their experience, some case studies, and some really good learnings that we can take into our own environments. So maybe I'm going to kick off, and Benoit, I'll start with yourself, if you don't mind, just to give a bit of background as to what you do and really what you're seeing in the space of water innovation in the work that you do. Thank you.
Thank you, Wendy, and greetings to our viewers and participants. Yes, I've been in the water and sanitation and waste space, so operating that nexus with energy for the last 40 years, dare I say, and the landscape in South Africa specifically, and I think there are some similarities in the rest of Africa, is where we're reaching the end of our water reserve, and the water reserve is also being faced with a whole lot of, let's say, demand issues and, let's say, contamination, pollution issues through industrialization, agriculture, and the likes. What we really didn't need the last couple of decades was the private water sector. So the infrastructure provision sector, from finance through to capacity building to the EPCMs, the engineers, we didn't really need to be organized. And so what we decided to do a few years ago is to really open that bridge with the South African government and the new administration. And using the Public-Private Growth Initiative, the PPGI, we were able, as a sector, to place water that had been forgotten, believe it or not, that water is actually fundamental not only to life, but to any economic activity. That was greeted by the presidency who chaired the PPGI with big business at the time, with a bit of shock and amazement. We've had a decade of, let's say, we had no master plan in place and all the likes. Don't want to dwell on those things, but what we said is that whilst government is organizing itself with the new administration, and putting a master plan out, the private sector needs to participate, always has, and I think there are different avenues in participating, but we needed to build that bridge and collaborate. And I must say, many within our sector said I was wasting my time, our team was wasting our time, but many also said we're not wasting our time. And I must say that 3 years later, we have a master plan that's been published. The water security framework has been updated through the National Planning Commission, where we've had direct input. And what we've really said is that the future lies in, private sector participation, and that applies for all sectors, but the water sector has always been lagging to an extent. And I think people only really worry about it, be it business, government, society. We only worry about it when the taps run dry. And same as energy, when the load shedding starts, we start thinking, must we do renewables? Do I need inverters, batteries, and all the likes? So, in South Africa, we're no different really to rest people in the world, let's say middle income countries. But we have a water crisis, and we have the technology. We have the legislation in place. We have three things, though, that we're not happy with, and that we're working in getting right is really the pillars of inculcating water security is policy certainty, contracting certainty, and regulatory certainty. And those three things, I believe, they can always be refined. So they're never perfect, but we're making great headway in working on those. And they touch with most government departments, maybe not tourism directly, but most of them. And I think in Africa, we have very similar situations where we can actually share probably our collaborative efforts in working together. So in a nutshell, that's really where the South African Water Chamber is coming from. A bunch of volunteers, scientists, engineers, financiers, and we're really trying to unlock the master plan. And the big difference we have in South Africa, which may be different to other regions, is that our bulk water through our surface and groundwater is virtually all allocated and catered for. We are dammed out, that's for sure. Now we have to start doing circular things like efficiency drives, reuse, and tapping into the biggest water reserve, which is the sea. And that is very different as opposed to building big dams and interbasin transfers that we're very good at. So we have a very different approach. It's required different thinking. And, I really like to say there's no box. So and master plan is very broad from that perspective, that the game is now at local government level. And we know the challenges we have at local government level. And the question is how, through our three spheres of government and business, how can we actually collaborate to unlock our water security?
Great, thanks so much, Benoit. I think that's really, really interesting, and we'll touch on some of your work a little bit later. Gerardo, can you take us through your background, where you come from, how you're involved in water innovation?
Thanks, Wendy. Welcome to all the listeners and participants as well from my side. So I'm by far the junior in this panel discussion. I'm working towards my first decade in industry. I'm a chemical engineer, registered with EXA. I've had the good opportunity of working predominantly in water treatment from the get-go, moving from a quick start in petrochemical industry and then heading towards Gauteng and basically falling into the mining sector. I've been in the consulting or the construction industry for providing water treatment solutions for various industries, and then spent the bulk of my remaining years in working directly in the mining sector as an in-house consultant in the environmental and water treatment departments. So my experience is much more based on the ground, the implementation of new technologies, and actually seeing what impacts new legislation has on mining houses, specifically on their water discharge qualities, but also water use. And I've been very fortunate to see from when I started, where new legislation was just being brought in, on how water should be handled, and that there's actually quality discharge limits, as opposed to in the past, water was very much just as an add-on or an afterthought for the mining industries, and now it's on the forefront. Recent new publications in water conservation demand management have put very well-defined guidelines in place as to how mines should look at water as a key part of the process, and also the recent Day Zero challenges that was faced by the Western Cape has shown many industries how critical water is to the entire process. It's probably just an ingredient in many of their processes, but it can bring everything to a grinding halt if it's not there. So it's been I think an eye opener for industry to realize that it's not just part of your bills that you have to pay. It's an integral part, and you have to handle it as such. So we cannot just use water without considering where you can reuse the water to use it more sustainably. And my speciality is also more in water treatment, so a wider range of active treatment technologies such as reverse osmosis, ion exchange, precipitation, but also biological treatment is a big part of wastewater treatment, which is predominantly your domestic users. So where industries might be focused on using active technology, biological treatment is by far the predominant technology utilized for domestic wastewater. So there's space for both kinds of treatments. There's also a lot of talk about passive treatment technology, which is being focused on for mine effluent treatment in some spaces, but also for other industrial wastewater treatment. Passive treatment is also an option. So there's a wider range of technologies that we can utilize for water treatment, and the more we focus on getting the sustainable answer, I think we're moving closer to where we can get a type of circular economy on water use.
Excellent. Thanks so much, Gerardo. I think coming from sort of more the energy sector and having sort of things like the IPP program, and we know those structures and we know how we can generate power and feed it to ourselves, etc. I think the water sector is sort of following in that, perhaps. But I always say, it's a lot easier to go and generate your own power than it is obviously to find your own water. We can go and get a generator, we can go put up renewable power, but you can't just generate water. And so it's just so much more of a complex issue. So Des, again, over to yourself and the work that you're doing at the Water Research Commission.
Thank you, Wendy, and good day to everybody. It's lovely to be here, and I hope we can have an engaging discussion. I am indeed from the Water Research Commission, and our business is trying to organize to get higher levels of water security and meet the basic needs of people through knowledge and innovation. And I'll talk a little bit about that just now. I have a little bit of a history with NEPAD. I was part of Professor Wiseman and Kushler's team almost 20 years ago now that brought together something called MAP, the Millennium Action Plan, and the Omega Plan from Francophone Africa into this instrument that eventually became NEPAD and today is the AU Development Agency. So it's a chance to remember some of that. I also play in the NGO space. I'm president of something called the Human Right to Water, which is a global organization seeking to do exactly what it says, realize the human right to water. But let me talk about Africa and water and infrastructure. Any engagement on the African continent in this domain requires us to have a confluence of three drivers. The first of those drivers is the basic needs driver, and the SDGs is the proxy currently for that driver, because this is the agenda that's dominating the countries of this continent, the continent as a whole, and in fact, the entire world. Organizing with those markers around an end to poverty and an end to hunger, there is a very important place for water and for sanitation and for wastewater inside that. But that's one of the drivers. A second of the drivers is the prosperity driver. And we've found expression of this in Agenda 2063. And a lot of the infrastructure plans associated with the movement of this continent is in fact housed in the Agenda 2063 and its various components in each of the sub-regions. And the third is around risk mitigation. And the biggest risk mitigation factor that we have to consider currently is, of course, climate change. I mean, the most modest of scenarios are telling us that sub-Saharan Africa will have twice as much impact around climate change as the rest of the world's average. In fact, when the world is talking about a 1.5 degree increase, we're talking about a 3-degree increase corresponding to that 1.5 degree increase. And we have to really organize for ourselves to think of all of this together. And water is quite central, of course, to both realizing the development potential, to organizing for us to meet the basic needs of all of the people on this African continent, which is going to be the most populous continent on Earth by 2050. And of course, we have to do it in a way that mitigates the climate change crisis. And it is here, it is real, it is not just a matter of the future. So critical to all of this is what kind of innovation we can put into the system. How do we build the capacity across the continent? There are certain countries that have a little bit of a head start, but we want to build this right across the continent. And we want to organize to have some export ambition for the solutions that we develop inside this continent. So let me talk about a couple specifics, and we can pick some of those up in the discussion. So one of the things that we're looking at, and we've built a wide body of knowledge around this, and the WRC operates with a very wide range of partners in South Africa, across the continent, and in fact, across the world, is organizing for water-sensitive cities and towns on this continent. And this is really, really important. This is organizing for the water ecosystem inside a town, better still, a city, to organize to have a reduced ecological footprint outside that city for its water needs and dealing with its water waste, and organize to increase its water security inside as well. And central to that is the One Water concept, where we have to have a recognition that one of the sources of water are our rivers and surface water systems. We have to add to that the groundwater systems. We have to add to that the recycling and the reuse systems. And we have to add to that the water demand management and water conservation. And when we have all of that together, then you have the right kind of infrastructure investment around water to guarantee water security. The next I want to put into that mix is the whole issue around new sanitation. Now, new sanitation, and this has been driven in large part by the Bill and Melinda Gates Foundation Reinvent the Toilet campaign, which started 10 years ago. Now this is the 10th anniversary, around re-looking at sanitation as a whole. Organizing to have either low water or no water solutions, and that's a very important characteristic of new sanitation, but also around beneficiating the waste and decentralized treatment of sanitation waste. And I think that Africa is well poised to become a global leader in this new sanitation concept. And the regulatory environment is now beginning to catch up in the form of non-sewage sanitation. And a combination of these issues, including things like the water, energy, food nexus, are, I think, the fundamental building blocks for the future infrastructure for water and sanitation on this African continent. And I think if we do it well enough, we will be exporting those solutions, not only to the developing world, but to the world as a whole. Wendy, I think I'll pause there and we'll pick it up in the discussion.
Fantastic. Thank you so much. That's really interesting to hear all the work that you're doing. It's really, really great. So, I mean, we've spoken about water scarcity, and we've spoken about water quality. And obviously, you know, scarcity is demand management, efficiency, looking after really what you've got. How how, maybe you can give us some examples of like specific innovation that has been applied in both of these spaces. I know there are some amazing projects out there, and maybe just highlight some that you're seeing. Des, again, maybe you can start and then move on to the other panelists.
Certainly. In this domain, in fact, South Africa has global leadership in parts of this domain. And one of the South African difficulties is that while we have very good candidates to begin with, our scale up and rollout is fairly limited. Let me give you a couple of examples. One, we have in this country organized to have pressure regulation to a degree of sophistication that at that time was matched by nowhere else in the world. And the pressure regulation, intelligent pressure regulation systems is a fantastic way to organize for reticulation integrity. You can deal with the leaks issues, you can deal with the demand issues, you can deal with the demand management issue from a centralized level. And I say intelligent because it has to have a timetabling, because there are times when people need the water pressure and there are times when they don't. So that's one very good example. A second example that I think is going to rapidly take over in water systems all over the world is the purple pipe system around organizing for reuse to become a major component of water supply. Only a small percentage of the water in an average building, certainly in the household, is needed at potable water quality. For most of the other uses, we don't, and we aren't organizing the thinking around this in a smart enough way. And then there are the litany of innovations that are coming out of places like the WRC, but other places as well, around intelligent control systems. One example is a product called Gizi, which monitors your geyser and organizes for your geyser's thermoregulation to happen in a smart way, saving you energy, and energy saving saves you water, obviously. But more than that, it organizes to monitor the integrity of your geyser system. And if there is a problem with it, it sends you an immediate signal that you can control. And now a major insurance company on this African continent is in fact investing in this as part of their own risk mitigation. So there are ranges of tools that are already at play and in demonstration that show us what is possible and what can be done. Maybe I pause there.
Great, thanks so much. Gerardo, maybe some of the innovations that you're seeing in your space and across the mines. I mean, they have such an issue with water into their mine, as well as obviously making sure that they're discharged responsibly.
Yes, thanks, Wendy. Definitely in the mining sector, there's a lot of focus on the water treatment. A typical term used very frequently is acid mine drainage, but that might not be the correct way to refer to it. But basically what happens is in the ore material, there's sulfide containing minerals. When they react with air and water, they create basically free acidity. And this also results in the dissolution of metals. Dissolved metals are dangerous to living organisms. And that's what is the focus for removal before that water can be discharged. There's a variety of other salts that also go into solution that need to be looked at, but the primary focus would be to get those hazardous metals out of solution. Now, this can be tackled with a variety of solutions, where I guess reverse osmosis is the most widely known, but it's a very expensive and high energy technology to apply, but it can give you potable water at the end. Whereas a more familiar solution that has been implemented across the Witwatersrand basins would be the high density sludge process, where you first focus on increasing pH and creating oxidizing conditions to allow for the precipitation of metals. And then you can settle out those in the solid phase, and then your water has a much lower risk towards living organisms, and then that can be discharged. I think another space where there has already been a lot of innovation and there's continuous research is in wastewater treatment, utilizing organic processes or biological processes for to create a safe discharge, but also in the utilization of the byproducts that are formed. In Europe, there's already a big uptake on creating biogas, or basically methane gas, from wastewater works. And there's very little or few wastewater treatment works that are not implementing that, where we have the same potential to be utilizing that. And it's only being done in very select wastewater treatment works, but it is being done on at government wastewater works. And then there's also in the private sector, a lot of wastewater works that are tapping into that renewable energy that they can access there. There's again also mentioned something about the purple pipe system. There's already bylaws being worked into some of the municipalities that when you're building new infrastructure, there has to be a grey water system as well as a potable water system. And that, I think, is a very big move, and there's a very big opportunity there, because he's very correct in saying there's a small portion of water that has to be potable quality for human consumption. But a lot of the water we're using for washing and showers, and they're not being polluted as much as that your domestic waste is being polluted to. So if you can split those systems as well, reuse your grey water or your processed water, that reduces a big part of your domestic consumption. And in your cities and villages, domestic consumption is your biggest consumption. So that's a way to tackle that. There's also unique innovation. I know University of Cape Town, they are pushing on a technology where they can create biobricks from urine, which is basically through a precipitation reaction. And that's another innovation where you can actually create a valuable or a usable product from a traditional waste product. And something that's also being implemented is fluidized bed reactors in a precipitation environment. And typically when you have a solution that's got a lot of metals or salts in it, and you start precipitating or forcing precipitation to take place to target some metals or elements, those elements are being formed in solution. So they form very tiny crystals, they're difficult to handle, they form sludge, and sludge is also a high water component. So if that's your waste stream, you're losing a lot of water. So the innovation in the fluidized bed reactors is creating conducive environments to force the precipitation to take place on existing crystal structures, thus creating bigger particles which are easier to handle, and which can possibly be reused in some way or form as a byproduct. So there's definitely a lot of space where innovation is being pushed, and there's no silver bullet for water issues. We need to look at each specific situation, what the problems are, specific elements of concern, and what the final end use of that water is. And that's the way we need to provide water solutions, or driving towards water solutions.
Great, thanks so much, Gerardo. That's really interesting to hear some of those examples. Benoit, maybe over to yourself. What are you seeing, and how does innovation sort of fits, or specific innovations fit into the framework of the PPGI? Is there sort of a work stream that encourages innovation and shares it, and how, what are you seeing? Because you spoke really about efficiency and reuse. So is that really where you're seeing a lot of the innovations coming out of?
So, within the PPGI is really, its function is to remove obstacles and hurdles that inhibit private sector investment projects. So obviously from a water perspective, that is a very small percentage. But we really focus on waters and institutional capacity and constraint removals. Whereas people like Desigan and his organization in the Water Research Commission, WESA and their working groups and the likes, look at the specific technologies. But to add to technologies, what we're seeing out of our membership and the likes is to build on if you look at acid mine drainage, we're squeezing out. So the pre-treatment is inorganic using HDS type processes, so physicochemical processes up front as a pre-treatment to the membranes. We're able to squeeze 98 to 99% of the water out of that acid mine drainage. Now, when we talk desalination in general, it's anywhere between 50 to 80%. So groundwater, maybe 80%, 90% recovery, seawater, 50%. What's, I think, very salient, and we're at the forefront here, is that we're able to squeeze the most water using membranes, so not using thermal processes, out of saline wastes. And that's leading us to the brine economy, which is absolutely gearing up to boom, and it's driven by the US and by the Saudis in the Middle East at the moment. But we've been doing it, I think, without thinking necessarily brine economy, but we've been doing this for 15 years already. And we take it for granted. We think it's a South African problem. It isn't. To add to this is that a lot of the salts we're able now to separate using, again, UCT was mentioned by Gerardo just now. So eutectic freezing, for example. The question is, is the energy footprint still too high and the likes? In other words, instead of applying a positive temperature, put a negative temperature. So we're able to separate salts, and now there's the market for salts. And if we just look at lithium, it is, with hydrogen, probably the lowest hanging fruit in the raw material called water. And so mining these raw materials, the gases, hydrogen, the most populous element we know in the universe, and mining the various salts like lithium, not only will we break, let's say, the stranglehold some of the big economies I won't mention who've got on that, we're able now to mine, and the ocean is infinitely renewable from that perspective. So it is really circular. So if you add to this, I think the thinking we have in South Africa and in Southern Africa, because of our mining pedigree, is in actual fact key to unlocking the brine economy. The second thing is we are the reuse champions of the world from a direct perspective. And indirect, we reuse most of our water because of the way our topography is that, and we've got to be careful with reuse. So I'm a big proponent of it, but we've got to be careful because many people are dependent on the return flow. So we've got to strike a balance, and the return flows are for the cities and towns downstream and agriculture and power generation upstream, for example. So now we have another, what I think is a certain amount of silver bullet in it, is the remix process, which is for our coastal towns going to sort out many of our water scarcity issues, completely decoupled from climate change. And eThekwini has installed a proof of concept plant, I think about 6 million liters a day, 6 megaliters a day, which is big for proof of concept. And I think the full scale being designed is going to be in the 50 megaliters a day. So the treated sewage on our coast, generally speaking, goes through outfalls into the sea. What we do is we take that, we then send it through to the seawater reverse osmosis plant, and the water we take out, at the moment in the proof of concept, the water is going back into the sea. It's not being put as a risk mitigation measure into the potable network, but it's perfectly good for, we've been doing this in Windhoek since 1966. So it's perfectly good for potable water, but even better, let's say, for industrial commercial water. And the brine stream that returns back into the sea, where we've taken the pure seawater, is in actual fact the same concentration of brine. So this only works obviously on the coast, but what it does is it reduces the osmotic pressure we need, so the energy we need, making the water produced a lot more affordable, 20 to 30% cheaper because of the lower energy footprint. Now, if I jump over to cities, we've got seawater around for a lot of our metros, and that water is now the global best practice, which is in the MENA region. Their seawater reverse osmosis, without using the remix approach, is cheaper than our average utility water that we have in South Africa, which is from surface water. With the escalation we've had in that, is that in actual fact, seawater desalination using reverse osmosis over the next 5 to 10 years is going to be significantly cheaper than our surface resources. The thing is, what do you do if you don't have water? You don't have industry, you don't have life, poverty increases, people fight over it and the likes. So between what we've learned in mining, in squeezing water out and in selectively precipitating salts, I believe we're able to address the two resources, the brine side of the input into our resource value chain and the water side. And that thinking is now being applied, but not being driven by South Africa. And I think this is where we need to put our hats on, and we need momentum. And we need a fleet of plants to be able to pull, so that the research, development, proof of concepts become South African. And this forms part of our industrialization master plan that we're busy developing with the DTIC, so that we can become a net exporter of water technology and supply chain items, be it from pumps, valves, and the likes that we import at the moment, that we export that plus IP. We mustn't forget. And I think into the African continent, we're an ideal startup or incubation hub where we restart this. And we could do this in West Africa, in Central Africa, and in East Africa. We have all of the basic ingredients to do that. So I think it's a mixture of resource management, circular approach, and IP development. Then obviously where I come from, doing it as an EPC.
Fantastic. Thank you so much, Benoit. And I'm going to ask Des again, because I could see you nodding through quite a lot of those comments, I think, especially around the seawater. But just to the delegates that are on the or listening to the discussion, please don't forget to use the chat box for questions, and hopefully our delegates can answer them as we go. But Des again, yes, I saw some nice nodding there as you went. Anything to add to what Benoit was saying?
Yeah, absolutely, Wendy. I think we fall short of recognizing the jewels that we actually have. And acid mine water is a great example. And the extension of acid mine water in the broader desalination space around new water coming into the system is something that I think we need to ramp up in very powerful ways. And, you know, Gerardo talked about the high density sludge process and the reverse osmosis process. And yes, they are costly, and yes, they use a lot of energy. But, you know, we have 5 other technologies, including eutectic freeze, that have been proven either at laboratory scale, and in the case of eutectic freeze, actually in a demonstrator plant, a 10 megaliter demonstrator plant, that solves both of those problems simultaneously. It now needs to be upscaled into actual use inside the system. And one of the things that we're currently experimenting with is alternative energy sources to run these desal plants. And we have a demonstrator currently operating using solar power. So the future around that looks extraordinarily good. But I want to add 2 more things to that mix, because it isn't only about technology. There are other things that need to go into place to make all of this stick into a powerful business model. The first of those things I want to put on the table is what the president talked about in the SONA this year in February. He talked about the notion of independent water producers, and he left it out there. And he was saying, as we have seen in the electricity sector, that this old notion of having the public sector completely dominating the supply space, maybe in the water space, is something that has a distinct timeline. And this is something we need to explore, we need to unpack. The WRC is doing some working papers on this, on the different models in which this can happen, because you need to bring the private capital and the private expertise in to make this move all over the continent. And then the second thing that comes along that, which I think is crucially important to the African infrastructure agenda, is the free trade agreement. The African Continental Free Trade Agreement is explicit that it would have preferential rules for the internal players in Africa around supply. And this is something we have to get into in an extremely powerful way. And there's an enormous water market on this continent. And there is some supply in places like South Africa, places like Egypt, in places like Nigeria. We need to ramp those things up to become preferential suppliers in the African context. If we don't, and if we don't do it quickly, the space will be taken up. There is a powerful world out there with good technologies and good expertise who also want that space. So I think that there's a stimulus that we need to move inside this direction. The other point I want to add to the mix is that we need to talk to things in the nexus. Yes, it is difficult to get bankable water projects because they're generally long-term. The price of water in most places in the world, maybe parts of South Africa excluded now, is generally cheap. And it does not have the same kind of return on investment ratios that you see elsewhere. But there are newer things that we should be looking at. One of the new things that is in fact old is this combination of water and energy. I mean, most dams around the world got their funding on the back of the hydroelectric schemes that were associated with the dams, because the energy returns is what paid for that infrastructure. We can go much further than that now. Now we are playing with something called conduit hydropower, where we're actually harvesting the energy from inside the pipelines, because there's a lot of energy inside the pipelines with flowing water. And you have a whole new system of hydropower that you can think of on the African continent. So the African continent currently, sub-Saharan Africa, is about 14% dammed compared to its potential. The way I think you reach the other 86% is organizing for that water to be related to something like energy, certainly to be related to something like agriculture. And when we start packaging those things inside the nexus, I think that's when we're going to start seeing the real bankable water infrastructure projects on this continent. Thank you.
No, that's fantastic. And I think that's, for me, myself, the energy, water, agri nexus or food nexus is really where my passion lies. And there's some wonderful examples of that, around the world. I think Australia's has put up a huge tomato greenhouses, which, utilize desalination and through solar panels to do that. So there are some examples around the world. Where do we sort of look to for examples, and where do we, how does technology in the space or innovation in the space grow and develop, and more importantly, how is it funded? If someone's, and how is it shared? How do we? Because really water is so important for everybody. It's not something that really needs to be, held to your chest and kept a secret. So how are these innovations shared, and how does one company that's struggling with, to get water or to discharge better quality water, where do they look to for innovation and these sorts of things? I'll throw it out to anybody.
I think I'll put my hat in for an answer on that. I think what everyone's looking for is that they want water, but they don't want to pay too much for water. That's what Desidean also said, is that mostly in South Africa, water is still very cheap. And it's not a big, it falls under your utilities when you typically have a process facility or something like that. But when you have to start looking at eutectic freeze or zero liquid discharge water treatment, you can easily go, the costs are becoming more competitive, but you can easily look at something like 2 to 4 times what you used to pay for water. Now you have to start paying this increased rate for water. So that's a big, I think, barrier at the moment for implementing these new technologies, but it's continuously being improved. Those costs are coming down through injury recovery systems, through better technologies or improving those technologies. We're moving closer to be able to provide that what was previously niche water treatment technologies, you can now get at much more competitive prices. But what we've seen in industry a lot of times is that it might not be that well known what specific technologies are available for water treatment. So there's, I think, a big onus on the industry players or the technology providers to try and get as much of that knowledge out as possible. And obviously everyone is trying to do that, but you are limited as to what your audience is. So I think it's very important that in opportunities such as these, where there's a very wide audience, that different technologies are put up on the pedestal to be able to give people the options in technologies that can be implemented for treating their specific water solutions. And then just I think there's sometimes isolated water plants going up in various areas. Industries like mining houses or big industrial processes, they have the funds to provide their own water treatment facility and give them their own potable use. But as Desigan also said, the return on investments on these plants are not very high. And what you want is you want the plant to be as big as possible to give you better return on investment. So I think an opportunity that we have there is similar to what DMR and Department of Water and Sanitation are trying to do in the mining sector. Is they're trying to look at regional closure solutions, but part of that is water is integral to that. So if you have in your metros, you have various big players with their own water treatment facilities producing their own water. If there's an opportunity there to, through collaboration with the government, create almost like a combined entity that's producing any excess water that they can produce at potable standard, we need to have somewhere they can push that water, and then that can basically be a top up to your municipal water sources. And if we can, I think that's a way where we can establish additional potable water supply, and then provide also a space where new companies can come into and provide funding for water treatment, and then also feed into that, because as a specific entity, it's not very easy to produce water and put it into a wider distribution network. But if we can start, if a lot of players are already doing that and creating potable water, and there's somewhere where there's an usable offtake, then I think that will promote further development and almost promote the development of more similar solutions.
I think it probably is, going to become a space that is similar to the electricity industry, because, we're starting to get wheeling, and we're starting to get, split contracts where a power plant can generate power as off-takers. So it's probably what we spoke about earlier, that whole independent water producers, because the feasibility is really in the size there. Desigan?
There are two things that I want to emphasize. One is that you asked who knows about this. Well, the R&D community knows a lot about this. In fact, there's a daily mantra of frustration expressed that why aren't these guys using the solutions that are out there? And there is a bit of a lethargy in the system, one has to admit, because in the WRC, for example, every single one of its projects has a project report and a technical brief, and these are freely available on the website. And we have a large number of people that use it, but they're primarily other researchers and consultants. Industry does not engage the space. So we're also working on different mechanisms on getting this out there. But the second part of this issue is that once something is proven at laboratory scale, no matter how excited folk like me get about that, it has to go to the next step of demonstration to mitigate the real risk before people can invest at scale. And this is a domain where there is a very limited funding availability in the South African environment and certainly in the African environment. And this is something we really have to bridge. But we are working on other things like smarter portals to get information out to people as quickly as possible. And one of the aspects that is becoming quite prominent in this independent water producer paper are the support mechanisms that will be required to offer state-funded leverage for private sector capital to come into the system. And this is when we're going to get the system to start flowing in a much more reasonable way. I think it will happen because the last 10 years, the weather patterns in sub-Saharan Africa in particular have been so extreme that we're no longer having theoretical discussions around the impact of climate change. We are in a water crisis in general in sub-Saharan Africa. Saharan Africa has always known this. And that's part of the reason why they have some of the more exciting technologies that are at play. I mean, to sell the concept of desalination in a place like Dubai is a no-brainer. There is no discussion. You know, you either invest in that technology or you don't have water. And I'm not quite sure yet what it takes for us to be there, because we have been on the brink several times. In fact, periodically every 7 years, we go into a drought cycle. We just had a long interval before the last one that made us very complacent, but that's the switch. The second is that if these other factors, these value add factors like energy supply, like nutritional security, like health security, because the primacy of water in the COVID crisis is now clear to everyone in the world. Maybe this is the edge that is required to get us over that brink into real investments in the domain. We do not have a technology shortfall. We do not have a science knowledge shortfall. We have a whole series of other innovations that need to come into the space, as well as some brave investment to give it a kickstart. And then we too could have a very vibrant water security business on this African continent.
Well, that's fantastic, and I think that's so true. You know, we have it's really all about you know, out of challenge comes opportunity and innovation. And so until you're not challenged with not having water to utilize, you know, like we saw in the Cape Town, the Western Cape droughts, you know, when you don't actually have it, or you're limited and the cost goes up, you know, that's really when the change starts to happen and people start being innovative and thinking, you know, on a very basic level, I'm going to, you know, put a bucket in my shower and water, try and keep my vegetable garden alive, you know. But unfortunately, human nature is that way. So we have to see those sort of crises to encourage some of this innovation. But it's great to hear that you know, that whole innovation network is strong. And I think what we really need to consider is how do we get these innovations funded and you know, get them further than proof of concept so that we can actually use them in various forms throughout our businesses and throughout our continent. So maybe we sort of have a few minutes left, but maybe in closing, if I can ask you each, how sort of what is in your space of work, what is really your hope and aspirations? And if there's any sort of a closing comment that you would like delegates to take home with them, you know, maybe just a closing comment from each of you. Benoit, I'll start with you.
Thank you, Wendy. Yes, and just continuing on the theme that was spoken about now, to us, the kernel of all this is the IWP principle. And it was our first port of call, was the IPP office when we started the PPGR process. And why we say that is that we're at the moment, when we go out and we look for water and wastewater infrastructure, our consulting engineer will build up a scope and it becomes a shopping list. And that is stifling innovation and access to technology. Through the IWP principle, one of the benefits will be is that we go out and we say, this is the problem, bring your solutions, and go through a series of RFIs before you go to RFPs. Test the market for knowledge, not for prices, for knowledge. Then what you do is you rank the responses, then go out on an engineering or technical process, and then go on to the commercial. So 3 rounds. Let me tell you, the world is a very small place, but all the operators will come in. So it's very much like our energy market that's very constrained. We need to open up on the water side, and all of these technologies will start flowing in on the back of the private sector. And as Desigan says, is with some, let's say, catalytic investment on the pre-feasibilities, bankable feasibilities, we now have a very bankable sector. And I think what we're about to do, the dawn we're on here in South Africa, can be emulated, at least in sub-Saharan Africa, quite easily on the back of our free trade agreements.
Great, thank you so much. That's yeah, really pertinent points. And yeah, I think the energy sector has got some really good learnings that we can take from it. So we look forward to seeing the IWP space really growing, and I guess in that sector as well, you know, when the IPP the RE IPP program started, the pricing was so high, you know, the tariffs that we could get to were so high, but as we've seen over the years, as the market develops, those tariffs drop. So as adoption takes place and implementation. So, you know, really hoping to see a similar sort of trajectory in the IWP space, certainly. Gerardo, would you like to sort of give us your vision of the future, what you'd like to see?
Yeah, so like I said, I think a lot of big players are already implementing water treatment technologies, and I agree there are some constraints with people trying to stick to a standard shopping list for water solutions. But I think there are also some of the industries that are willing to take the risk on new water treatment technologies. So I think there will be a lot of exciting opportunities to implement these technologies, and also to prove that they are viable on a big scale. And I think there's a big opportunity for private industries with their own water treatment to create a space for quicker development of independent water providers. And I think we need to, again, create a space where they can link up, not just water-wise, but also infrastructure-wise, so that it's not all up to municipal or government water distribution networks, but that there's money and a drive to develop additional water distribution network and supply. So I think we currently in a space where it's starting to grow, but we can push it a lot harder and create a solution before we are at that critical point where, okay, sorry, there's no more water.
Yeah, absolutely. We don't want to get to that point. Again, yourself, what is your vision for the future?
Well, Wendy, I have a very optimistic vision for Africa and water. I genuinely believe that Africa, more than any other place in the world right now, has the best opportunity to leapfrog the current difficulties that we have around water and energy and waste management and security in the world into a much better space, into a much lower carbon space. And the way to do it is for us to organize for this platform, this African platform, to be a global testbed. We should be inviting all the global players to come right here into this African laboratory, test out what is possible to organize for us to be in a completely different future with much higher levels of securities. And I think people will respond to that invitation, because the nature of the greenfield sites that exist on this continent are not replicated elsewhere in the world. You know, it's predicted that we will have 50 megacities by 2050 on the African continent. And at least half of those are currently small towns. They're not even small cities. So you have the opportunity for that water-sensitive design, for the energy-sensitive design, for the nutritional security design into those settlements like nobody else can do currently. We have the opportunity to build out those next-generation wastewater treatment plants that are in fact energy generating as opposed to energy consuming. We have the opportunity to also perhaps introduce into the world a much smarter set of mechanisms around how the public sector and the private sector and civil society, so if you like, a public-private partnership getting together to organize for us to have the kind of water security that we want going into the future. And I hope we can do that.
No, that's really wonderful. I think that's a beautiful vision and so important. And let's just do it. Let's use platforms like this, Infrastructure Africa. Thanks for the time for us to be able to have this discussion. We've spoken so much about, not so much about the challenges, but obviously the innovation and the opportunities. And there's certainly enough innovation out there. There's certainly enough technology. We need to share that, and we need to adopt these technologies. And we need to not wait until, we're back into further crises. A real good vision for all of us. So I'd just like to thank you all for joining the panel today, and really appreciate your input and your time. And I hope I see a lot of your visions implemented into the future, and I hope to have a similar discussion in a year or two and pick up on where you've all got to. So thanks so much for your time and your input.